This is Climate One. I'm Greg Dalton. Together, cement and steel account for about 15% of global greenhouse gas emissions. But look around our modern world, and it's hard to imagine building much of anything substantial without them.
Carbon emissions from the built environment is still going up. Buildings are more efficient, but there are more of them every year.
Technology exists for making lower carbon cement and steel, but at a premium price.
The industry really needs to up its game. They didn't have incentives earlier to optimize for carbon emissions. They were optimizing for something, and that was cost.
So how do we eliminate emissions from two of the world's most climate-destroying industries?
We have the technology to do that today, so we really need to start thinking about how we scale that deployment.
Turning down the heat, decarbonizing cement and steel. Up next on Climate One. Along with aviation, the construction industry is one of the hardest sectors to decarbonize in the global economy. Carbon-negative cement has been talked about for years, and innovations in steel production show promise as well. But is either technology ready for prime time? And what about replacing these materials with engineered wood, which could also store carbon for decades? John Fernández is professor of architecture at MIT and director of MIT's Environmental Solutions Initiative. I asked him what makes construction materials such a challenging problem.
Cement, steel, aviation, shipping, those are some of the most intractable areas for reducing carbon emissions, partly because these are industrial processes that actually don't have a good alternative today to produce at scale and economically the materials that are used for the primary materials used for construction. This is the wicked problem, these materials in construction. When you're talking about carbon emissions in the construction industry, you have to talk about steel and concrete to begin with. So, for example, every ton of steel produces about 1.85 tons of carbon dioxide. Now, that's coming in steel primarily from the high temperatures needed to process steel. It comes to some extent from extraction activities as well, but the high temperatures in processing are where that's coming from. Concrete, it's slightly different. So for every ton of concrete, you're emitting about a half to maybe 0.6 tons of CO2 for every ton of concrete. And it's coming from two different places. The two places are the actual chemical process of producing cement itself and making that clinker, that's the word for the actual binding material in cement, actually is a CO2 producing chemical process. So actually directly from the chemical process, you're producing CO2. But then also, just like steel, you're doing that in a very high temperature environment. You've got 2,600 degrees Fahrenheit. And of course, to produce those high temperatures, you're burning energy, and there's a lot of emissions coming from, primarily the combustion of fossil fuels to do that.
Right. And a lot of consumer-facing brands are doing things to address their supply chain, the inputs, where they get their water, where they get their wood, Forest Stewardship Council, those sorts of things. But here with buildings, isn't consumer-branded buildings. Where's the pull, either the market pull or the policy push to get cleaner steel and cleaner concrete?
Yeah, well, so there is certainly both. There's the market pull. So it's very clear that the market is valuing green buildings. And this is not new. In the United States, I was involved in the beginnings of the United States Green Building Council. And in the early days, it was just a few people going to their conferences. And the market was the obstacle because you actually couldn't produce a net zero energy building. Amazingly, the market really turned around and is very well positioned to supply the devices, the materials, the assemblies needed for high performance buildings and even net zero energy buildings. So there's definitely a market pull, and the market pull goes all the way back to the finance and the tenants. And we see in buildings, in fact, here in Boston, there's a building that's a passive house rated building. It's a commercial office building. It's actually going to be the largest commercial office building passive house in the world. And a passive house refers to the idea that a system of high performance windows, natural ventilation, super insulated exterior walls, and good thermal mass. That means enough mass in the building to retain heat. These things come together as a system and substantially reduce the energy consumption of a building to about 65 to 85%. One of the very nicest things about the Passive House story is that the source of heat is the sun, but it's also people and devices like computers. By coming to work, you're actually lending your body heat to heat the space, which gets circulated throughout the space and helps to actually create a comfortable interior temperatures. I know because I've been involved in that building that one of the major tenants signed a lease specifically because it's Passive House, because they want their employers to feel good about coming to work. And these days, getting people to go to the office is a major challenge. So there's definitely a market pull, but the push has to be there too. And the push is happening at the international level, beginning with the international level with the Paris Agreement, but then national determined contributions for carbon emission reductions. The built environment has been for decades and remains the low-hanging fruit, the smartest dollar you can spend, primarily in efficiency in reducing carbon emissions to meet your goals, your nationally determined goals for carbon reduction. So there is definitely a role for government push, but as we know, it's not strong enough. Construction has a long way to go. The built environment needs to reduce its carbon emissions by half every decade. And carbon emissions from the built environment generally, from buildings generally, is still going up. Buildings are more efficient, but there are more of them every year.
Elsewhere in the program, we'll be talking specifically about reducing the carbon intensity of cement and steel. For those who don't know, what is mass timber and how does this carbon math pencil out?
Yeah, so mass timber is an umbrella term. There are actually a number of different types of mass timber. There's a glulam, so this is a type of glue laminated lumber. There's laminated veneer lumber, which is LVLs. There's the cross-laminated timber. Cross-laminated timber is an interesting material because you are orthogonally crossing layers of lumber, I should say. So we're talking 2x4 sized lumber, and they're stacked together, they're glued, and then the next layer is orthogonal to that. It's basically a very large-scale plywood, right? And the fact that you have orthogonal layers means that it's very dimensionally stable and the strength to weight ratio is very, very good. But all of these types of wood fall under an engineered wood label. So mass timber buildings are primarily engineered wood buildings. But there is one other type, which is timber buildings. So we know, just a kind of post and beam timber building where the members are made not out of engineered wood, but out of single trees, right? So you think about, the ski lodge that's made out of post and beam members of wood. That's different from engineered woods.
You're saying it's almost said it's as strong as steel. Is it better than steel in terms of carbon?
Well, in terms of steel, so the dry weight of wood, of any piece of wood, about half of the dry weight of wood is carbon. So you've got two major elements in reducing carbon emissions when you're using wood of any kind, and mass timber, certainly. One is that you're sequestering that carbon in half the dry weight. The second is that you're replacing steel or concrete. So the amount of carbon that you're sequestering is just half of the equation. The other half of the equation is that you're displacing the cement or the steel that you would be using otherwise.
So I hear that wood is embodied carbon. You said about half of the weight of dry wood is carbon. That's versus steel, which creates a lot of carbon emissions because of the high temperatures in making it. Yet, so that sounds like okay, wood better than steel. But with deforestation being such a driver of climate change, why would we want to increase the demand for forest products and drive deforestation?
Yeah, I mean, so that's an excellent point. The fact is that's the other side of the consideration that's really, really important. the sourcing of the wood. So there's a global perspective, which is that in the developed North, and certainly in North America, forest cover is stable and has even increased over the last few decades. So forest cover itself, there's not a threat to deforestation in the United States and in Europe, and in fact,
although if I could jump in, Professor, the wildfires in the American West
absolutely
are taking out millions of acres a year. So that math,
absolutely.
has changed.
And part of the mass timber story is that the industry is keen to harvest a lot of that dry and dead wood, partly to reduce the amount of fuel in national forests. Certainly, there has been a lot of forest loss by way of fires, but again, over the several past decades, forest cover is relatively stable. There's not a worry of vast deforestation by way of industrial processes. That's a completely different story in the developed South. So in the global South, deforestation absolutely is an incredibly important topic. A good way of thinking about this is that the sourcing in the developed North has to be as local as possible. And I think some of the best demonstrations of this, there's a building in Norway. It's now the world's tallest mass timber building at 18 stories. And the source wood for that building and its mass timber columns and beams are sourced locally from Norway in a managed forest. And that's really the way to do it.
You're talking about the global North and South. That raises the equity question. The global North has a long history of, extracting. Some of those economies would be negatively impacted if they no longer were exporting products to the global North. If everything was sourced locally, wouldn't that hurt this?
So the next step, though, on the international trade of wood is managing the sources. So certainly I'm not advocating for no international trade in wood. I'm advocating for managed sources, managed forests that can provide the materials for engineered wood. And I am also just want to make sure that we cover the co-benefit of reducing biodiversity loss. So targeting small caliber trees, small dimension trees is important. Doing that in a managed way, and that can even be done in biodiversity hotspots. That those small diameter trees can be milled into engineered wood. That's one of the benefits of engineered wood. You take those small calibers and you process them, and then you glue them all together into a high performance wood component. That's a completely viable, sustainable strategy. And you can not affect biodiversity in that case. And that can be an internationally traded product. There's no question about that. I think the key is really not only the establishment of robust managed resources, but as with all things, continued enforcement and monitoring such that the resources is sustainably harvested.
You say that urban populations will double in the next 30 years, and about 90% of that growth will be in developing countries. The urbanization of China is one of the biggest drivers for carbon math, how China urbanizes, whether that's built around a single family car, the buildings and construction. You're the professor of urbanization. What's going to take for cities in those countries to implement the kinds of materials we're talking about, especially if they are novel and perhaps more expensive.
So in Africa, in South Asia, Southeast Asia, there is a real potential for using cellulose materials, and prime candidate there is bamboo and other engineered cellulose products. The real benefit there in a developing region is not only the avoided carbon from the reduced use in concrete and steel, but also the employment opportunities. So production of novel employment opportunities by way of the processing of these materials, and doing it at various scales, at a sort of small cottage scale to the industrial scale. So there's good potential in developing regions of the world.
How close could mass timber come to replacing the more carbon intensive materials? We often hear about this as an emerging category, how much of an impact could it make, both in terms of direct carbon sequestration and in avoided emissions for other materials?
Yeah. So honestly, it's going to be a very small portion, certainly of the sequestration or the storage of carbon. It's important to note that what we need today are solutions that are this decade. So we need carbon solutions this decade, next decade, but really we really need to be moved very quickly. Trees store carbon, but it takes them a long time to store carbon. So on the one hand, it's a long-term carbon storage solution. So ideally, one could imagine a future decades from now where there are many, many mass timber buildings, and there is a lot of stored carbon. In terms of the amount of stored carbon, it's not going to be anywhere near 1%. It's going to be much less than that, 1% globally. However, as you said, as much of the replacement of steel and concrete and cement that can happen by way of using mass timber buildings, that's really where the low-hanging fruit, that's where the greatest returns will be. So taking a dent off of the 8% of global emissions that are related just to cement production, if one were to take 1% or 2% away from that because you're replacing it with alternative materials and buildings, that's a major savings. So it's really the emissions avoidance by replacing concrete and steel to some extent.
John Fernández is professor of architecture at MIT and director of MIT's Environmental Solutions Initiative. Professor, thanks for coming on Climate One today and explain the built environment.
Thanks for having me.
You're listening to a Climate One conversation about reducing emissions in two of the most difficult to decarbonize industries, cement and steel. Coming up, the potential for making greener cement.
At this point, there's very low levels of alternative fuels or non-fossil fuel-based inputs that we use to heat the kiln at those very, very high temperatures. But in Europe, actually, you have a history of sort of using higher degrees of alternative fuels. From 2005 to 2019, the average share of heat from alternative fuels increased from just 16% to 50%.
That's up next when Climate One continues. Cement is the second most used commodity in the world after water. It's everywhere, and it's responsible for about 8% of the world's greenhouse gas emissions. That's rising as the world becomes more urban. When I look at sidewalks and highways, I see all that embodied carbon. Radhika Lalit is Chief Strategy Officer of the Mission Possible Partnership at the energy think tank RMI. When she looks at cement, she sees something more.
It's hard not to be impressed by the human ingenuity around the substance that's primarily just a binder, but that has something to do with some of the most beautiful marvels of built environment and infrastructure around us. And that potentially underpins development in our civilization.
I often ask people about their climate awakening moments, and I've never talked to someone before who went to a cement plant and thought of it beautiful and amazing. And thought, so this is a first for sure. And cement is a thing that is everywhere. I think sometimes people think of it as kind of, boring, take it for granted. How ubiquitous is cement in the built environment?
It's everywhere around us. And, it's the history that I'm most fascinated about, right? Like, this is not something that was just developed right now. You're looking at cement that was developed 12,000 years ago in some shape or form. We had a cement that helped build the Greece and the Roman empires. And, subsequently, in England, someone came up with Portland cement, which is the most important cement that you use right now. But it is all pervasive. And like I said, one of the most consumed materials in the world after water. So, you see it in the built environment. You see it in our construction of ports, all infrastructure around you, roads. So everywhere you see, you will find cement and cementitious materials.
I had no idea it has such a long history. If cement were a country, where would it rank on greenhouse gas emissions?
Yeah, well, it would be the third largest emitter of greenhouse gases, only behind China and the United States. You're looking at around 7 to 8% of global emissions per year, which is quite substantial. And, more than half of these emissions are actually coming from China, which actually is world's largest producer as well. And then the distant second is India, which makes up for like 9% of global emissions with regards to cement and concrete. But yeah, it's too big to ignore.
And it's everywhere. And I have climate eyes. Everywhere I look, I see embedded energy in every product that I look around, like, oh, there's energy there and water to make that. When you look at cement everywhere, how does it make you feel? Do you see like, oh, this is so big? Do you feel dread or opportunity?
Like I said, I'm fascinated by this one material that has kind of taken the world in a different place. I think, it is the bedrock of economic prosperity, and I definitely think that we've been using more and more of it. So I have mixed thoughts on that. But just let me take you through the journey of how much production has happened. So roughly, the production since 1950s has increased by more than 30 times. That's roughly 4 times since 1990s. And China alone has used more cement between 2011 and 2013 than the entire United States did in the entire 20th century, which has led to its development.
Let me get
Yeah.
that. China in a couple of years used as much cement as the United States did in a whole 20th century. Wow.
Yeah, it is wow, right? That's why this is what fascinates me, and it's only going to grow. Like, of course, China has peaked its consumption almost, and the future growth in construction industry is going to dictate where more cement and concrete production and consumption is going to happen. But largely, South Asia, Southeast Asia, Sub-Saharan Africa are going to be those markets that we will see this consumption taking in, place in, and it's going to be rapid. It's going to be rapid, and it is driven by urbanization, population growth, economic development. Yeah, and you're looking at roughly 5 billion metric tons per year within the next 3 decades.
Can you walk us through how cement is traditionally made and why it's so carbon intensive?
Yeah, absolutely. So traditionally, the Portland cement is made by calcinating limestone, and you do that in a rotating kiln. So you heat up that temperature, you kind of put the crushed limestone in it, and you produce something called clinker, which is the binding agent in cement, right? The clinker is then ground with sand and gravel to create the cement. This chemical reaction is the very basic reaction that we've been doing since 1845. The chemical reaction itself is around 60 to 65% of the emissions. And this process is called calcination. Essentially, you break down limestone to produce at very high temperatures, and what it decomposes into is lime and CO2. So the chemical reaction itself, as you can see, kind of releases CO2, and that's the majority of the emissions. The 35 to 40% of the emissions then come from really burning coal or fossil fuels or natural gas to really achieve these high temperatures in this kiln.
So, two big levers to reduce emissions: high heat and the chemical process itself. Let's start with the heat and the energy input requirements. What can be done there? Is it basically fuel substitution, moving away from coal to something else?
That's exactly right. I think at this point, there's very low levels of alternative fuels or non-fossil fuel-based inputs that we use to heat the kiln at those very, very high temperatures. And that is the case in most economies, but primarily, the big ones, US, India, China, you have very high, amounts of pet coke, coal, natural gas that is being used to sort of heat the kiln at very high temperatures. But in Europe, actually, you have a history of sort of using higher degrees of alternative fuels. So an example of that is roughly in Europe from 2005 to 2019, the average share of heat from alternative fuels increased from just 16% to 50%. One particular country kind of jumps up, which is Poland, where the alternative fuels increased from 14% in 2005 to 70% in 2019, which really means then several plants in Europe and specifically Poland have achieved really 90% of heat substitution from alternative fuels. And that is thanks to very good regulatory environment, social acceptance, and a lot of investment support.
That's a big deal because Poland is a coal country. The second big lever, changing the chemical process used to produce cement, the chemical reaction that produces most of the CO2 from this industry. So what's the state of technological innovation there for greener cement?
Yeah, there's several levers to sort of curb carbon emissions within this 60% of the chemical reaction itself. One is, of course, to use less, which is material efficiency essentially. And what that is essentially, I like to break it down into 3 R's. One is you reduce the amount of clinker in cement by substituting it with alternatives. So what that is in our common language here, we call it supplementary cementitious materials. And what that really is fly ash, slag, and other materials that help substitute the amount of clinker in cement itself. The second R of this is really readjusting the way clinker is made, and that is by reducing the amount of limestone in feedstocks or modifying the calcination process itself. So there is some innovation that is happening on that. The third piece is really reformulating the cement chemistries by developing new binders or novel materials and low carbon processes. So there is definitely movement happening in the innovation space across all the 3 Rs, which is specific around use less or material efficiency. And then the last and the most important lever, which actually, some say could contribute as much as like 40% to the decarbonization story of this sector, is really carbon capture, utilization, and sequestration / storage technologies.
So lots of opportunities there to do that. Of course, we've been hearing about clean or green cement for some time, but a lot of these promises don't really scale. We hear about something that's like, "Ooh, cool! This could have a huge thing," and then they fade. So, what's the prospect for scaling cleaner cement?
I personally think there's a lot of potential, but there are also several barriers. I think the first barrier is really around the price premium. This is called a hard to abate sector because it's extremely hard to abate, and any changes in technology really do mean that this is going to be expensive. So, just as an example, if we were to say today, let's, use CCS, CCUS on a cement plant to reduce emissions.
That's carbon capture and sequestration. Yeah. So,
yes,
okay.
Exactly. That itself will add $100 per ton to the cost of cement. So how do you pass on that cost to something that's highly commoditized? It's a huge barrier. Price premium will always be a huge barrier. The second barrier I think that several startups and innovators need to think through is really regulatory policy and testing standards. Several of the regulatory standards right now on cement and concrete tend to be quite prescriptive, and we really need to move from prescriptive to more performance based standards as a way to redefine this industry. And so that is definitely something that is a potential barrier. I'd say that there is also a demand side barrier where there isn't enough demand for something new, something different. There's different users and consumers and across the cement and concrete use, and you have engineering companies, construction companies. All of them may or may not be willing to purchase a low carbon product. So the demand signal needs to be stronger, which it isn't at the moment. And then I think lastly, I would say that there is a barrier around policies and incentives for decarbonization itself. If we did hypothetically have a carbon price, then of course you would price these externalities or these costs into the production, and therefore it would be a level playing field. But that's not the case, and that's not the reality we're dealing with. So, lack of these policies that address carbon will lead to higher costs, higher first costs, and therefore there will be some concerns across the board for how do you overcome these costs and barriers. And yeah, I mean, another one that comes to mind would be around, perception. There's a lot of perception issues around, is this new cement or new concrete, alternative cement or alternative concrete, really have the strength as the traditional ordinary Portland cement? And that is something that will always be challenged. And so how do we overcome that perception barrier as well, with data, with more information out there? It's really important.
I went through something like that personally recently where I was doing some construction work at my home in California. So it has to have really strong footings, and said to the architect and manager, like, I want some low carbon cement. And they kind of looked at each other like, oh, what does that mean? Where do we get it? Is it going to be strong enough? Who's going to get in trouble if it doesn't, perform? And eventually, and they think they found some with fly ash. But thinking on broader scale, I'm thinking of some things like LEED buildings, for example, where there's kind of a consumer facing, where large corporations say, we want LEED gold or platinum buildings. Does that include cement? Because without any kind of consumer facing, you call it demand signal or pull, it seems like there's not going to be that price premium. With LEED buildings, people do pay a little more for recyclable materials, all the things that go into a greener, they're willing to pay that green premium. Is that connected to cement or not?
Yeah, no, definitely. LEED standards have, they talk about embodied carbon. They talk about, and the largest embodied carbon comes from steel and concrete. So the two materials. So definitely it is part of the standards. To your question earlier, is like, how do corporates or big procurers who are looking to buy into, buy low carbon cement and concrete today, how do they work around this problem of finding the right supplier, finding the right quantities, being able to compare likes with likes? And I think this is a real problem. And, there's a lot more progress that needs to be made and will be made over time as we start to optimize for carbon emissions rather than just costs and costs itself. But there is a tool that I think I want to make a plug for, which is the EC3 tool by Building Transparency, which by the way is free to register, and anyone can register. Anyone, a homeowner or a big corporate, anyone, or a government, and that collects EPD data, which is basically the performance data of cement and concrete, and it allows you to compare one cement and concrete vis-a-vis another through the different parameters. So it allows you to sort of, at least there is a tool that allows you to compare like with like, and sort of give you an understanding of what is the embodied carbon within each of the different cement blends that you will buy, and how will that make a difference to your net goals.
The Buy Clean California Act just went into effect on July 1st, and it puts limits on the global warming potential of certain materials, mainly steel and glass, used in state building projects. Cement isn't on the initial list, but could be added in the future. How much of a difference would that make?
Buy Clean is a great example of public procurement policies that will incentivize the producers of these materials to really, make those investments, those big investments for decarbonization. And so, like you said, California doesn't have it, but you have Colorado, New Jersey, New York. All of them have passed legislation on cleaner concrete. And the trend is that this is going to grow beyond just these states that I named. And of course, there's Buy Clean policies at the federal level as well, that the Biden administration announced recently. So this is huge, right? Public procurement is a huge lever. And I say that because governments are the largest buyers of cement and concrete. It goes from 20% to like 50% and beyond of these products. And so when such a large buyer of your material makes a demand for lower carbon product, then you see change coming. And it's not just, procurement doesn't only have to be public, but I'm also seeing trends around, corporates coming together and saying, we'd like to buy and procure low carbon concrete. And there's a recent movement around that started by the climate group, Concrete Zero, it's called. And this is where corporates are signing on to commitments to buy low carbon cement and concrete. And this is what we need, right? We need the demand side to come together. We need the finance to support at very and incentivize, and then we need policies that really help further this along. And this is exactly what success looks like.
I can see that happening in rich countries where there is pressure on corporations to measure their supply chains and the inputs into their buildings and factories, et cetera. When we've talked about cement being a commodity and the industry being focused on cost and most of the future demand growth in the developing world, you said Southeast Asia and Africa. So how can we expect them to pay a premium for greener materials when they're just trying to get their countries out of poverty?
It's such an important question. And, there is no easy answer. There is no one silver bullet because, like I said, there are interventions that have to happen at every level where, you literally start at the design stage and you say, how do we use less materials in the first go? Then how do we use lower carbon materials when we have to use those materials? Then how do we reuse? And for developing economies, there needs to be this trifecta of finance coming together, and that could be enabled by multilaterals and other developed countries who could give concessionary finance to help spur lower embodied carbon materials, steel, cement included. And then the industry really needs to up its game. And like I said, they didn't have incentives earlier to optimize for carbon emissions. They were optimizing for something, and that was cost. They were giving you the lowest cost product. But now they need to give you lowest cost product at the lowest carbon.
Radhika, Lalit is Chief Strategy Officer at the Mission Possible Partnership at the Rocky Mountain Institute. Thank you for making cement exciting.
Thank you for having me, and this has been a wonderful conversation.
You're listening to a conversation about decarbonizing cement and steel. This is Climate One. Coming up, like cement, the production of steel requires intense heat, which accounts for the lion's share of its carbon footprint. But that heat does not necessarily have to come from burning fossil fuels.
Green hydrogen, we typically refer to that as hydrogen being made by splitting water through renewable electricity with an electrolyzer. So that green hydrogen, because it's coming from a renewable electricity source, the emissions are low, and the byproduct just being kind of oxygen and water vapor from that.
That's up next when Climate One continues. Steel is surprisingly recyclable, but we can't use recycled steel for every application. To make primary steel, one needs high heat to reduce the iron ore into iron. Chathurika Gamage is manager of climate-aligned industries at the energy think tank RMI. She explains that when cooked coal, or coke, is used to reduce iron ore into iron, that chemical process itself emits even more CO2.
The process of turning iron ore into steel actually makes up about 7 to 8% of global emissions. And that iron making part is the carbon intensive. So to dive a little bit deeper into that, that's really due to the coke use, or coke is also referred to as, cooked coal. And that's used mainly for high heat purposes within the blast furnace, as well as a reduction agent. So the main ingredient in steel is iron. And to get that iron, we need to first reduce the actual molecule, which is iron ore, extract that oxygen off. So you're left with iron, but you're also then, because the carbon binds to the oxygen, you get CO2. And so that process will need high energy sources and a reduction enabler. And those options exist, and we need to kind of accelerate that a little bit further.
So what are the pathways to, perhaps, changing that manufacturing process?
Yeah, so for starters, we have a different technology that actually makes about 10% of global steel at the moment, which uses natural gas as that reductant and heating service. And that technology is called direct reduced iron, or DRI for short. And just using natural gas instead of coal, emits about 50% less per ton of steel. So that technology is, tried and tested, it's out there. And then in terms of, moving towards technologies that can go beyond that 50%, or what we might call as, deep decarbonization technologies for steel, we've got several options, primarily sort of sitting in the buckets of green hydrogen, as well as CCS.
Why don't you define green hydrogen and carbon capture and sequestration? What do those mean?
Yeah, sure. So green hydrogen, we typically refer to that as hydrogen being made by splitting water through renewable electricity with an electrolyzer. So that green hydrogen, because it's coming from a renewable electricity source, the emissions are low, and the byproduct just being kind of oxygen and water vapor from that. So you would use that the same way that you would with natural gas in a DRI to produce green steel, essentially. And there's a few pilot plants that we can talk about that's doing great work in that region. And CCS is carbon capture and storage, very similar to carbon capture that's used in power plants at the moment or refineries, and exactly the same type of technology where you would place that carbon capture on top of, emission source point sources along the system, and you really have to then think about storing that carbon, or if you are utilizing that carbon, and that will have impacts towards what the footprint of the steel will be.
And you mentioned a couple of pilot projects producing green steel. If this technology works, why isn't it being deployed more widely? Is it more expensive?
It is more expensive. And so this is kind of the test in terms of when you think about technology scaling. So we have a few plants at the moment in Sweden that are, going through this, multi-million sort of ton scale that we need to see in sort of steel production. The green hydrogen is still cost prohibitive or expensive today, but we see those costs going down. RMI has reported on that, as well as external sources saying that even before 2030, we will see, green hydrogen being cost competitive with the other types of ways to make hydrogen. And therefore, that technology will naturally be picked up in the market because it provides emissions reductions, but it's also cost competitive.
Right. So green hydrogen made from renewable electricity, blue hydrogen made from fossils, but the carbon emissions are captured somewhere. All of this sounds very expensive. Sweden, think of as a country with a heavy government role in the economy. Where's all the money going to come from to make these technological transitions?
Yeah, so the money is, in terms of pulling this necessary demand, especially for first movers. So as we talked about, because, green hydrogen and those electrolyzers lend themselves to a learning rate similar to renewables. So we can see once we invest in these projects early, everyone will sort of reap the benefits, going forward. And so when we just focus on the money and who needs to pay for this and what support is available for these first movers, we can see necessary demand being pulled by either government support, as you talked about, just direct grant and fundraising. And then there's also pulling that demand through public procurement. So governments listing, that they need to purchase steel of a certain lower embodied carbon, for example, and private sort of demand commitments as well.
I was a little surprised and pleased to learn how much steel is recycled in the United States. And is there also an export opportunity for the U.S. to be an exporter of recycled steel?
Yeah, so I think the U.S. is certainly doing a great job. And it's also, when you think about the life cycle of steel a little bit. So we have so much recycled steel because we also made so much, decades ago, and therefore there's a market when that steel comes. Steel is essentially infinitely recyclable in the sense that, you can keep doing that. It has that physical property that allows it to be this way, and it's versatile, but it can't be used in everything. And so that's why, primary steel is also required. And to your question on could we be an exporter, I think certainly. But when we also look at the US, it also imports about 20 million tons of steel. So it's almost building that foundational base first of, do we want to, not be importing and be a country that, meets all of its domestic demands, and then think to expand that base and almost like reindustrialize US steel to become this exporter.
So we're importing primary steel because we don't make it ourselves, and there's certain uses for which recycled steel is not appropriate. Is that what that is?
Yeah, that's exactly right.
And what's driving the demand for greener steel? Is it auto companies? Is it companies making dishwashers and washing machines, like, who want to have a roll up to a brand level to say, hey, this is a low carbon product, both in its manufacture and its use? What's driving the demand for greener steel?
So when we think about private demand sectors that you talked about, there's groups that are trying to coalesce so you can send a much stronger demand signal. So places like the climate group Steel Zero Initiative and First Movers Coalition are trying to aggregate this demand. So certainly big sectors, offtake sectors like auto. So I think they use about 12% of the global steel that's made, because about half the material in a car is steel. And so they're pushed by not only regulators, but to your point, like very climate conscious consumers. And then it's almost a brand when you can sell that as a green steel product. And what we found is, through sort of supply chain modeling, is the premium that would be paid right at the end customer. So you and me buying a car, it's actually, would be about $400 kind of, per vehicle. So the pass-through costs would not be that much. And so we're seeing, the high-end automakers, so, Mercedes, Volvo, BMW already doing, sort of first mover contracts with the likes of Hybrid and H2 Green Steel and some of those green steel makers that we talked about, committing to, putting trucks, for example, with fossil-free steel on the market by, as soon as 2025, 2026. And that's, around the corner. So it's pretty promising.
You mentioned that the countries or regions best positioned to capitalize on a demand for zero carbon or low carbon steel are those with both plentiful iron ore and renewable resources such as wind and solar to power the production of green hydrogen. So which countries are best positioned, and where does that leave the US and China?
Yeah. So I think in terms of that combination, it's usually countries that might have a very small domestic production at the moment. So we see that as, an opportunity if they feel like taking that up. So certainly places like Australia, which is, the world's biggest exporter of iron ore at the moment, and, certainly a sun-kissed country in that sense, could forward integrate. Other places that I mentioned are, in Brazil, places in South America, South Africa, and some regions in North America. Canada, for example, is also looking at this, and that could, certainly be a pathway for importing into the US, given that we have quite a cordial relationship in terms of steel product going back and forth through the border. Where does that leave the US and China is, I'll tackle the US first. So we talked about the US being quite, different in the way that its steel is, assets are built up. We have a lot more EAFs, so ability to recycle. So EAFs being those electric arc furnaces. 70% of US steel is made through those electric arc furnaces, but the emissions number is flipped. And we have, obviously more emissions coming from the primary production. And so a chance for that to build on regions in the US like West Texas, or, the central plains, essentially, where high wind capacity. And there is, iron ore mines here, right here in the US, that are utilized for primary steel up north as well. And so we see that happening, but it might change the way that where primary steel is located. And so government support is needed to think about those existing communities, right, in the Rust Belt. And how do we support those communities to either, accept new green technology into that region, or think about, either having to move some of this production to where low-cost hydrogen can be made.
And while hydrogen is one piece, you also mentioned methane gas as a substitute for coal to achieve the high temperatures needed. There's quite a debate, as you know, in energy and environment circles about methane gas as a bridge fuel. Is it better than coal? No, so where do you come down on, you said what, 50% cleaner using methane gas than coal? Sounds like a good deal, but other people might say, no, we shouldn't, lock in more gas infrastructure because it's not what it's promised to be.
Yeah, for sure. And also, given the point that we see, green hydrogen becoming more competitive, or as cost competitive with blue hydrogen, within this decade, it sort of doesn't make sense from that aspect as well. But, certainly places like Texas and Pennsylvania in the US, as well as, other regions of the world that are so natural gas, heavy and have all the infrastructure and everything's built out, it seems to, as you say, it would make sense and it's a nice story. But when we think about the life cycle emissions, methane being a highly potent, global warming potential of over 84 times that of CO2, it's very crucial that the natural gas that is, supplied to make either blue hydrogen or, this other form of steel in DRI is the lowest it can be. And that can be through, getting certified natural gas, for example. And so those mechanisms exist that a buyer can be sure that every bit of the supply chain is as low emissions as possible. On the other side of the house is making sure that the actual capture on the CCS is also achieves, a consistent high capture rate. And so most of the existing projects of CCS in power, for example, are achieving high capture. But in terms of other industry, it's, really kind of falling to around 60 to 70%. And there's only one CCS commercial project for steel at the moment, and that is actually in place in Abu Dhabi. That capture is being used for enhanced oil recovery. And so when you think about, again, that whole life cycle, it might not, make the most sense from the environment's perspective on if true emissions were saved.
Chathurika Gamage is manager of climate aligned industries at the Rocky Mountain Institute. Chatu, thanks for coming on Climate One today.
Thanks. Happy to be here.
On this Climate One, we've been talking about decarbonizing cement and steel. Climate One's empowering conversations connect all aspects of the climate emergency. To hear more, subscribe to our podcast on Apple or wherever you get your pods. Talking about climate can be difficult, sometimes depressing, and it's critical to address the transitions we need to make in all parts of society. Please help us get people talking more about climate by giving us a rating or review. You can do that right now on your device. You can also help by sending a link to this episode to a friend. By sharing, you can help people have their own deeper, informed climate conversations. Brad Marshland is our senior producer. Our producers and audio editors are Ariana Brocious and Austin Colon. Megan Basilia is our production manager. Our team also includes consulting producer Sarah Catherine Coxon. Our theme music was composed by George Young and arranged by Matt Wilcox. Gloria Duffy is CEO of the Commonwealth Club of California, the nonprofit and nonpartisan forum where our program originates. I'm Greg Dalton.